Hello and welcome to The Print. This is Akanksha Mishra and you're watching Scientifix, where I will be taking you through this week's top science news from across the world. Our first story today is about new research from the Korea Advanced Institute of Science and Technology, where scientists developed a new spray-on powder that can stop severe bleeding in about 1 second, offering a potential breakthrough for battlefield medicine and emergency care. The study explained that this spray is designed to transform into a hydrogel the second that it comes in contact with blood, so that it can immediately seal the wound and stop severe blood loss. This technology could prove to be revolutionary for battlefields and emergency care in hospitals because current methods of stopping bleeding are still conventional, such as gauze, bandages, or tourniquets. The spray has been tested in labs to hold 7 times as much blood as its own weight. And it also has antimicrobial properties to ensure that the wound won't get infected. The paper said that the invention could help in combat and battlefield situations as well as in emergency care in hospitals and field clinics. Next up, researchers have found that honeybee queens that are exposed to pesticides can protect themselves by transferring the contaminants into their eggs, a process which is called maternal offloading. The study, published in Current Biology Journal and led by University of California, Davis, found that while worker bees initially filter most of the pesticides from the food, this defense weakens with prolonged exposure, which allows chemicals to accumulate in the queen. Experiments showed that queens then pass the toxic burden of pesticides to their eggs through their bodies, potentially affecting egg development and also contributing to long-term decline of the colony of bees. This offloading reduces the burden of pesticide content on the queen's own body. Researchers also found that pesticide residues increasingly accumulated in hive components like wax over time. The findings suggest that pesticide contamination may persist in colonies long after initial exposure, and it has implications for bee health, pollination, and agriculture. Next up, scientists from Case Western Reserve University in the US have found that microbes living in the Arctic permafrost exchange genes far more frequently than previously thought, a process that could influence how ecosystems respond to climate change. The study analyzed 8 years of soil samples from the Stordalen Meyer peatland in Sweden. Using advanced genetic analysis, the team identified around 2.1 million mobile DNA elements that are capable of moving genes between microbes, with evidence suggesting that gene exchange may affect up to half the microbial populations in a community at any given time. The researchers found that these mobile genes influence functions that are linked to carbon cycles, nutrient processing, and other essential cellular activities. As the Arctic permafrost thaws, such genetic flexibility could help microbes adapt rapidly, affecting whether vast stores of carbon remain locked in the ground or are released into the atmosphere like greenhouse gases such as methane, with implications for future climate change. Finally, scientists have identified the earliest known evidence of spider-like fangs in a 518 million year old fossil, shedding light on the evolution of one of the defining features of spiders and their relatives even today. The study that was published in Nature journal examined fossils of Urocodia, a marine arthropod recovered from the Chengjiang biota. Using X-ray tomography, scientists found preserved soft tissues, including primitive pincer-like appendages behind the animal's eyes that represent the earliest known chelicerae. These are structures that later evolved into the fangs of modern spiders and scorpions. About 2 to 3 centimeters long, Urocodia also showed features that resemble the gills that are used for breathing by modern horseshoe crabs, confirming that this fossil lived in the sea. The findings provide new insights into the early evolution of chelicerates, one of the most successful groups of arthropods on land and in water. That's all we have for you today. Thank you for tuning into The Print.